Hello, welcome to class today. Okay, today I'm going to be talking about the relationship that exists between the method of completing the square and the general formula that is used to solve a quadratic equation. Now, it's very, very important for you to note that there is a connection between those two methods. You can actually connect the general formula to the method of completing the square. Now, please note that this is going to be a long process, but I want you to just follow me gradually to understand this. There is a connection. Now, there are some equations in mathematics, some quadratic equations that you cannot factorize. That is when completing the square method and the general formula comes to play. Now, but there is a connection between the general formula and completing the square method. We can actually derive the general formula from the completing the square method using the normal and basic form of the quadratic equation, which you already know as ax squared plus bx plus c is equal to 0. So we are going to be starting with that equation. Now, generally any form of any quadratic equation is supposed to be in the form of ax squared plus bx plus c is equal to 0. So we're going to use that now, using completing the square method to get the general formula, such that you can either use the completing the square method or the general formula to solve any equation that is a quadratic equation that you cannot factorize. Simple! Okay, so ax squared plus bx plus c is our starting point. Now let's break it down. The first thing you need to do is to move your c to the other side of this equation. Now, if you move c is already positive. So if you move c to the other side of the equation, you're going to get ax squared plus bx is equal to minus c. You don't have any problem with that. Okay, so from this particular step, let's proceed to the next one. Now, what you need to do is to divide both sides of this equation by the letter a. Now, the reason why you need to do that is because we want to make the coefficient of x squared to be 1. Now, to achieve this, you have to just divide both sides of this equation by the letter a. Now, if you do that, you're going to be having ax squared over a plus bx over a is equal to minus c over a. Now, the a will cancel a, and you're not going to be having ax squared anymore. X squared will now be standard, but then the a will appear under bx and under c. Therefore, you're now going to be having an equation that looks like this: x squared plus bx over a is equal to minus c over a.